Hello everyone and welcome back to the next episode on how to create your very own programming language. So before this video starts, I just want to say thank you to my very first Patreon supporter, Daniel Munch, and I hope I'm pronouncing that correctly. So I really do enjoy making these videos, but of course if I'm getting a source of income from them as well, I'm able to spend a lot more time recording them, so thanks very much again, I really appreciate it. Also, this channel just hit 200 subscribers, so thanks for everyone who has been watching my videos and following this series. The other day I thought I was getting an average of about 30 views on each video, and I just checked my most recent one and it was over 200 views, so I was not expecting that. Finally, this is the third last episode of the series, so after the series I'm going to have to move on to another series. So I've put a poll on screen now of what series you'd like to see next, and there are a few options. The first one is going to be a simplified remake of this series. The next option is how to create your own custom data format, so it's going to be something similar to JSON. And then there are also a couple of other options. So now let's begin with this video. So first of all, we're going to update our language, and instead of looking for a single expression at the start, it's going to look for a list of statements separated by new lines. We're not going to be reading from files until episode 14, so we're also going to allow semicolons instead of new lines. We're also going to update the if expression to allow multiple statements. So if you put the expression on the same line, then you can only put in a single expression, but if you put in a new line, then you can put multiple expressions, and the last one is ended with the end keyword. The same thing will apply for the for statement and also functions. We currently don't have a return statement for functions, so we will be adding that in the next episode along with the continue and break statements. So we'll get started with updating the lexer. So we need to add in two new tokens, and that's the new line token and the end keyword token. So we'll add in new line, and we'll add end to this keywords list. So we now need to come down to lexer and create this new line token. So we'll add in a check here if the current character is, and we're going to allow either semicolons or new lines. So we can then just append a new token of type new line, and we'll pass in this position start as well. And we can advance. So now we'll move on to updating our grammar rules. So we'll start by adding in a new statements rule, and before we look for the expressions we can allow new lines, so this means 0 or more new lines, and for each other expression we want a new line with that expression, and we can allow 1 or more new lines, so that's what the plus symbol means. We'll put a star here, which means we can do 0 or more of these, so we can have as many expressions as we want, but we always need at least one expression. At the end of the statements we can allow more new lines again. So for the if expression we have to change it quite a lot, so I'm just going to start from scratch. So we'll create if expression, and we want the keyword if followed by an expression followed by the then keyword. We then want to allow a single expression for the body of this if expression, and we also want to allow the elif or the else section of the if expression, and we're going to move them into their own rules. So if expression B will be the elif, and if expression C will be the else. And I probably could have named it better. But again, we also want to allow new lines and multiple statements before moving on to the next section of the if expression. So we'll also add in the option for a new line followed by statements, and then followed by the same thing. And this symbol here means or, so it's either this or this. And actually also when we're doing multiple statements we want to allow the end keyword. Also after the single expression we want the elif and else to be optional, so I'll put a question mark. The reason I'm not putting it as optional here is because it's required if the end keyword isn't put in. So now the second part of the if expression, which is the elif, and this is almost identical, so we'll just copy and paste, and I'll change this to part B, and all we have to do is change this to elif. And after our body we can just look for another if expression B, so this allows multiple elifs in the if expression. And so now finally the third part of the expression, which is for else. We will look for an else keyword followed by a single expression or multiple statements when we have a new line, and when we do it this way we want an end keyword as well. So that's it for the if expression, and now for the for expression we want to allow a single expression, or we also want to allow multiple statements, so we'll just copy and paste that in. We can do that same thing for the while expression, and also function definitions, so we'll allow either an arrow and an expression, or a new line and multiple statements. So with those grammar changes we can now update the parser. So we'll start by adding in the new statements rule. So here we create an empty list of statements, which will be a list of expressions, and then we get to position start, which we'll need at the end of the method. We then want to skip any new lines at the start, and we then want to look for the very first expression, and we'll just add that expression to the statements list. We now want to look for more statements which are separated by new lines, so we'll check while the current token is a new line, and then we'll just skip that new line. We need at least one new line, so we'll create a new line count variable starting at 0, and we'll increment this count by 1 every time we come across a new line, and we're going to create a more statements variable which starts at true. However, if this new line count is 0, which means there's not at least one new line, then we can set this more statements variable to false. So if there's no more statements, we'll just break. So now we want to try look for an expression, and if there is no expression, then we know we've finished looking for the statements. So in this code there is currently no way of trying to look for a rule, so we're going to have to add in a new try register method. So what we can do is call expression, and we can use the try register method, and that can be assigned to statement. With this try register method we can check if the statement doesn't exist, and if the statement doesn't exist then we're going to have to use this new reverse method which we also have to create. So this will reverse by this toReverse count which is on the result. So the reason we're doing this is because once we call this expression method, the expression method would have advanced a few times, so we need to get this reverse count and reverse by that amount. So if you don't come across another expression, we can set more statements to false, and then we can continue, and in the next loop we'll check if not more statements, and then we break out of this loop. After we run out of expressions we want to look for more new lines, and since we continue to the next iteration, before we break we are already skipping all the new lines, so that already is implemented. So finally, if we do come across a statement, we can just call statements.append statement. So at the end of the method then we can return these statements, and we're going to put each statement into a list node so that each statement is evaluated. We could create another multiple statements node, but they both would behave in the same way. So we just need to fix a quick typo in the lecture. I called token.append here instead of tokens.append. So in the parse method of the parser, instead of looking for a single expression now, we can look for multiple statements. And now we need to implement the try register method and reverse method. So we'll come up to the parse result. So we'll create this new try register method, and we check if there is an error. And when there is, we set this toReverse count to the advance count of the result. So remember, we increase this advance count whenever we register an advancement, or whenever we register another result. And so we can take this advance count from the result and set it to the toReverse count. We'll also make toReverse count start at 0. We can then return none so that we can determine that it failed, and if it doesn't fail we can just call the original register method with this result. This original register method increases all these values and sets the result.error, so there's no need to duplicate that in this method. So we can finally add in the reverse method of the parser, so I'm just going to paste this all in. So what I've done is I've moved this section of the advanced method into its own update current token method, because we need to reuse that in the reverse method. So what we do is we take in the amount that we have to reverse and we subtract that amount from the token index, and then all we do is just call update current token, which updates the current token variable. So if we run the program now and we type in the statement, as you can see we now get a list of results back. So we can now separate each statement with a semicolon, and as you can see we get 3 results. And of course we'll be able to use new lines once we're reading from a file. We can also put in as many new lines as we want, and it will still work fine. However, there is one slight thing that I want to change, and that's when there's only one result, I don't want to show it in a list. I just want it to simply show the result as it was before. So we'll come into shell.py, and we'll just check if len result.elements is equal to 1, and we can then just print result.elements 0, so the first element, but otherwise we can print the entire list. And while we're at it, if you put in an empty statement you get this invalid syntax error, so we're going to also fix that. So what we're going to do is just check if text.strip is equal to an empty string, then we can just continue. So strip will just remove any white space from either end of the text, and it's often called trim in other languages. And once we strip the text and it's an empty string, which means nothing has been typed in, then we can just continue and ignore executing this code. So now we'll move on to updating the if expression rule. So what I'm just going to do is delete everything. So we'll start with the parse result, and then we want to look for all of this, and as you can see it's almost identical for if expression and if expression part B, so we're going to put that into its own reusable function. So in this reusable function the only thing that will change is the keyword name, which is if or elif, so we will take that in as an argument. So this function will be called if expression cases, and I could probably find a better word but it will do. So for the if expression we want to pass in the if keyword name, and this will just return the cases which we've had before. We can then check for errors, and this method will just return the cases which you've had before, and that was cases and else case, so we can get those out. And this will just simply return a new if node and pass in the cases and else case. This if expression cases method contains a lot of what we had before, which I just deleted a second ago, so I'm just going to go through what we've changed. So we're taking in that case keyword, we're creating our cases variables which we had before, and then we are looking for this case keyword, which will be either if or elif. We then look for the condition, which is an expression, and then we look for the then keyword, and here's now where everything changes. So we can now have either a single expression or a new line and multiple statements. So we check if there is a new line, we advance past this new line, and then we want to look for statements. As before, we can now append this to the cases list, so we pass in the condition, which is from here, and the statements from here. And we also have this new variable which I've added in, which is called should return null. So remember previously that we could use our if expression inside other expressions, such as the variable assignment. So then it just returns whichever expression is evaluated based on the condition, and assigns it to this variable a. But when we're doing multi-line statements, we don't want to allow us to use it inside other expressions. So this should return null boolean variable, which we will see in action in a few minutes. This will simply make it return the number.null constant instead of returning the actual evaluated expression. And remember, since we're looking for statements, this actual evaluated expression would be a list. So I definitely don't think we would want that. So now we can look for the end keyword, and if that's the case we're finished, but if there is no end keyword then we have more to do. So remember, if there is no end keyword, we want to look for if expression B or C, so I will be creating a method for that. We again get the cases out of that, and we then add these new cases to the cases list, which we have all the way up here, and this else case is also assigned. Now if we don't come across a new line, we have to go back to the way we were doing it before. So we're now just looking for an expression, a single expression, and we're adding that condition expression to the cases again, because a single expression if statement should be usable inside other expressions like we had before. So we again look for if expression B or C, and we add in all those cases. So at the very end of the method we just return these cases wrapped in result.success. So that was a bit of a longer method, but the other ones will be a bit shorter, so we'll create the if expression B method now. And we can again just call this reusable if expression cases method, and we pass in this elif case keyword. And unlike the if expression method, we don't have to do any of this creation of if nodes or anything like that, and instead we just return the cases directly, and we allow the if expression method to only worry about that. We then need if expression C, which is long enough again. So this part is only looking for the else section, so we create an else case variable, and else is optional inside the statement, so we just check if there is an else, and if there's not, we just return the else case, which will be none. So we advance past this else, and we look again if there is a new line, and if there is, we look for the statements again, and we set the else case to the statements, and we again have this should return null variable, which will be true for statements. And if there is an else expression, then this will be the very end of the if expression, so we want to look for this end keyword, and if not, we create this error. So if we don't come across a new line, we just do it the way we did it before. So we just look for a single expression, we check for errors, and then we assign the else case to this expression, and should return null is then false. So that is it for the if expression C method, and then finally we need the if expression B or C method. So this is used here and here, so there's no harm in putting it into its own method. So we again need the cases and else case. The elifs are optional, so we'll check if there is an elif. If there is an elif, we want to look for if expression B, which is the section that looks for elifs. So we can then just assign the cases and else case from this result. So if there's no elif, which means we're not looking for if expression part B, then we want to look for part C, which is the else expression. So we just assign this else case, and then at the very end we just return the cases and else case. So that is it for the update to the if expression, and it might have been a bit complicated, but at least that's out of the way, and now we're moving on to the easier parts. So for the for expression rule, we need to again add in a check for the new line. So after the then keyword, I'll just paste this check in. So when we get a new line, we're now looking for statements followed by an end keyword, and we are again adding this new boolean value should return null, and that's true here, and we have to set that to false here. We have to do the exact same thing for the while expression. So after the then keyword, we'll add in this new line check, but this time everything's the same, but this time we are returning a while node, and we have true here, and we again need to put false here. Function definitions are a slight bit different because we have an arrow before the expression. We were previously checking for an arrow and then creating this error if there was none. So we're now going to remove this error, and we're going to put this inside the if statement. And don't forget to change this from not equals to double equals. So we'll do this in the case of an arrow, and we'll do all of this in the case of a new line. So if we don't come across a new line, we need to say we expected an arrow or a new line. We advance, and then we look for the statements, we look for the end keyword, and we then return the function definition node, and we again have this should return null variable, which is true. And we need to also add it in up here, which will be false. So before we move on to updating the interpreter to allow for this new should return null variable, we need to actually add this new variable to our nodes. So for the if node, the should return null variable is inside the cases and else case tuple. Now previously else case was not a tuple, but it was just a single value. So because of that change, we just need to move this to after the parentheses. This just ensures we're getting the first element from either of the tuples, which is the node, when we're getting the position end. So now the for node, while node and function definition node need to take in this should return null variable. So we'll just assign that to self.shouldReturnNull. We'll do the same thing for while node. And finally function definition node. So now we'll come down to the interpreter, and we'll come down to the visit if node method. So now we want to take this should return null value, and when we are returning out of the function, we want to check if should return null is true, and if that's the case we return number.null, but otherwise we return the expression value. And we can do the same thing down here. Also, there's a problem that has been around for a few episodes now, and as you can see at the end of this method we're returning none. The problem with this is that we have to work with our custom types in these visit methods. So instead of returning none, we want to return number.null. This should sort out any errors that you might have been seeing with the if expression. So now we'll come down to the for node, and at the end of the method we want to again check if node.shouldReturnNull is true, then we return null, otherwise we return the value. We'll do the same thing for the while node. And finally we need to update the function execution. So we're going to need to add in another should return null value, which is passed in, and we assign that to self.shouldReturnNull. And inside execute we can check if this value is true, we return null, otherwise we return the value. And when we create a copy of the function, we need to also pass that in here. So inside the visit function definition node now, we can just pass in node.shouldReturnNull. Now once we add return statements in the next episode, we will be changing this up again, but for now we'll just keep it like this. Also, I forgot, in the visit if node we need to actually get the expression and the should return null values from the node.else case, and we should be passing in the expression here, and now that should be working. Okay, so that should be it. We can now run the program. So again we can put in multiple statements. We can use the if expression we had before, so we can do var result equals if 5 equals 5, then mat works, else no, and the result variable is now mat works. But we can also do multi-line statements now, so if we do a semicolon, now we can do print mat, print works, else print broken. So that works fine, and the same thing applies for for statements, while statements and functions. So that marks the end of this video, and don't forget to leave a vote on which series you think I should do next. If I do end up redoing this series, I will focus more on the concepts so that it's easier to apply to other languages other than Python, rather than focusing on Python specific ways of doing things. I also intend on showing you how to add unit tests to your language, which is very important if you have any proper language. In the future I will also have series on compiled programming languages and also advanced interpreters, which will involve garbage collection. So again, in the next episode we will be adding break, continue and return statements. And thanks again to my very first Patreon supporter, Daniel Munch. So thank you for watching, and I will see you all next time.